Welcome to Matter and Energy, our second unit. So, everything in the universe is classified as either energy or matter. So, what are those? What is the definition? Well, the definition of energy is the ability to do work. That's kind of a basic definition, but it's true. So, doing any kind of work requires energy. It is the opposite of matter. Matter is anything that has mass and volume. And we're going to learn later that volume is anything that takes up space. So I chose these cubes because they have mass and they have volume. And volume takes up space, so that's matter. So a candle itself would be matter, but the heat and light given off from that candle being burned is energy. So here are some forms of energy. The first is chemical energy. And chemical energy might not be something you're familiar with. So you might want to add this additionally. Chemical energy is energy, oh my gosh, not so clear today, energy stored in chemical bonds. Okay? Chemical energy is stored within the bonds. So since it is stored, this has potential energy characteristics. Heat and thermal are the same idea. Heat moves, thermal energy, they move, so this has kinetic energy characteristics, okay? Then we have light energy, which is kind of the same as solar and radiant. So again, we have not yet talked about kinetic and potential energy in this class, but hopefully you know that kinetic energy is energy of motion, potential energy is stored. So light moves, so this has some kinetic energy characteristics. Nuclear energy. Nuclear energy comes from the nucleus of atoms. And it's energy stored in the nucleus of atoms. So again, if it is stored, this has potential energy characteristics. Mechanical energy, that's energy of motion. Okay, so again, if we're talking about motion, that would have the kinetic capabilities. Sound, you know that sound travels in waves, so that has kinetic capabilities. Magnetic energy, again, the force of those moving electrons and moving charges, that would be kinetic. And the last one is electrical. You know, this is the one with the moving electrons. That is kinetic. So really, these are forms of energy that can be under the umbrella of kinetic or potential. And if you are stored, that would be potential. And there's only two here. But all those other ones show movement, and so that would be kinetic. So here's a flow chart. Matter can be broken down into something called substances. And substances are uniform or homogeneous. Sometimes pronounced homogeneous, but I usually say homogeneous. Uniform means the same throughout. So substances have a definite structure and a definite formula. So you can write out the formula. So this is where our periodic table is going to come in handy, because substances are things like elements. So we've got carbon, we've got fluorine, we've got sodium. That is not sodium, that's nitrogen, but we could add sodium. Those are all elements, which means they have a definite formula, which means they are substances. But if I were to combine elements together, I call those compounds. And so those are also what we call pure substances. So we have water, H2O, we have sodium chloride or table salt. That is a compound of two different elements. If you are not pure and the same throughout, you're something called a mixture. Mixtures are a blend of two or more substances in a variable ratio. Notice how when you have water over here, there's always 2 hydrogens for every 1 oxygen. If you change that ratio from 2 to 1 to 2 to 2, which would be a 1-to-1 ratio, or 2 to 3, then no longer are you dealing with a pure substance. So there are 2 kinds of mixtures. There's homogeneous, sometimes called homogeneous, and we call those solutions. There's a whole branch of solutions chemistry we're going to talk about later in the year That'd be things like saline. Saline is salt water. So we take the salt, we dissolve it in the water, we stir it up, and then you can't see the salt anymore. That's called a solution. It's the same throughout. Kool-Aid, same idea. You put the powder into the water, stir it up, it becomes dissolved. Bronze, a mixture of different metals. You have to melt them down because those solids aren't going to mix each other on their own. So you have to melt them down, but then they become a mixture, the same throughout. Then, of course, we have heterogeneous, which would be different. Things are like soil. In soil, you see there's like the maybe rocks or pieces of grass or stones or humus, which is like the brown, like earthy stuff. All those different things. Chex Mix, which is a variety of different pieces of, the kinds of squares, and then they have the little bread things, and then the swirly girly bread things. So those are heterogeneous mixtures. That's all I'd like to say today, and thanks.